Hi class, so today we're talking about like terms and as it relates to the topic of polynomials. So I'm just going to get right to it, give a definition. So like terms, they are going to be monomials with identical variables raised to identical exponents, or I'll say the same exponents. So I've underlined the word identical, so that's very important. So I'll give you some examples of things that are like terms and things that are not like terms. So like terms. So one example would simply be x and 2x. That's a very simple example of like terms because they have both of them are monomials, and they both have identical variables, which are x, and the x's are raised to the same exponents. In this case, the exponent is 1. Another example, negative 3x squared and like 1/7 x squared. So same idea, both of those are monomials. They have the identical variables, they're both x, and the variables are raised to the same exponent, which is 2. So it does not matter what the coefficients are. Those numbers in front are the coefficients. They do not determine whether or not terms are like terms. It's only the letter parts and their exponents that matter. I'm going to give some examples that are not like terms, and we'll go back and forth between giving examples of both kinds until hopefully you get used to it. So x and x squared, for instance, are not like terms. They both have the same variable, x. However, they have different exponents, so that's not allowed. Negative 3x and 1/7 y. Those would not be like terms because they have different letters altogether. One's an x, the other's a y. They do not count as like terms. Okay. You can have more complicated variables, letter parts. We can have products of variables. For example, 2xy squared and 6xy squared. Those are examples of like terms. Both monomials have an x and a y. The exponent on the x's of both terms is the same, it's 1. And the exponents on the y's of both terms are also the same. The exponent of y is 2. It has to be perfectly identical like that for the letter parts in order to be like terms. So an example of what's not like terms, I'll start with 2xy squared again. But for the other one, if I say 6x squared y, those are not like terms. So they have the same letters, x and y, but the exponents are not matching. It has to be the same exponent for the same letter. So for the first one, x has an exponent of 1, but for the second one, x has an exponent of 2. They don't match, so they are not like terms. Okay, so we have 3 examples here of like terms and 3 examples here that are not like terms. Even though the last one's like pretty close, it's not good enough. It has to be the exact same letters, the exact same variable. So I'll give you another example of something that's not like terms. Let's say a squared b squared, and I'll say b squared c squared. So that's also not an example of like terms. because both of them have b squared as part of it, so that's identical, but the a squared is not identical to c squared for the other one, so those do not count as like terms. A squared, b squared, and let's say b squared, a squared. Actually, that does count as like terms. Both of them have an a, both of them have a b, and they have identical exponents too, squared on every letter. So it doesn't matter what order you write, you multiply the variables. The rule is just identical variables raised to the same exponents. Okay, so that's what's like terms and what's not like terms. And why are we talking about this? So basically, we're going to now talk about adding and subtracting polynomials. So here's the main point for today. When adding or subtracting polynomials, only like terms can be combined together. I'll use the word simplified actually. Only like terms can be simplified. We can collect like terms together and simplify it by adding or subtracting them. And we add or subtract them simply by adding or subtracting their coefficients. We add or subtract their coefficients. So I'll give lots of examples here. Okay, example 1. I'll say 3x plus 4x. Okay, that'll be my first example. So we're asked to add those together. When you add, what you do is first you check whether or not they're like terms. And yes, they are. They both have the variable x raised to the exponent 1. So they're identical variables with exponents. So that means we can add them. And according to what I wrote in blue, you add them by adding their coefficients. So the coefficients are 3 and 4. So 3 plus 4 makes 7. And then you copy down the variable part exactly as is. So in this case, it's x. Okay, so I want to make sure you're clear that 7x is the answer, and it is not 7x squared. Okay, 7x squared would be a mistake. That's wrong. X plus x does not make x squared. X squared represents x times x, but it does not represent x plus x. So you don't add the exponents when you're adding or subtracting. Don't get it confused with earlier in the unit when you did exponent laws. Okay, so another one. What if you don't see a coefficient? So for example, y minus 4y. So first you check, are they like terms? Yes, they are. Both variable parts are exactly the same as y. So now we subtract their coefficients, and you don't see a coefficient for the y. You need to recognize that that actually means 1y. So what we're doing is we're subtracting 1 minus 4. And so we have to remember our integers. 1 minus 4 ends up being negative 3. And we write y, negative 3y. All right. I said that some people make the mistake of saying y squared. Other people may make the mistake of just saying negative 3 by itself, thinking that y minus y goes away and you don't write the y anymore. So that is not correct either. You have to write the y in there. I can let y represent present, okay? Y is a present. So if I have one present minus 4 presents, I'll end up with negative 3 presents. I guess that doesn't make sense in real life, but maybe I'll talk about number 1. Okay, X will represent presents. So if I have 3 presents plus 4 presents, what do I have? I should have 7 presents. So 7x. I can't just say the number 7. Okay, 3 presents plus 4 presents does not equal the number 7. It equals 7 presents. So you do have to attach the variable after, and don't forget about it. Okay, so another one, I will say 2a plus 3a plus 4b. Okay, 2a plus 3a plus 4b. So are they like terms? Well, the first 2 terms are like terms. The 2a and 3a are like terms, but the 4b is different than those. So in this case, when we simplify, what we do is we only add together what we can. And the stuff we cannot simplify, we just copy it down. So that means simplifying the 2a plus 3a to give 5a. A can be apples. 2 apples plus 3 apples equals 5 apples. And then we copy down the plus 4b. Maybe those are bananas. So at the end of the day, we have 5 apples plus 4 bananas, and that's all we can do to simplify it. You cannot add an a with a b, so 5a plus 4b would actually be the answer. Question 4. Let's start adding some exponents in here. So I can say 6, I'll use the letter p this time, 6p squared minus 3p squared. Okay, so that can be done. Are they like terms? Yes, they are. They both have the letter p to the exponent 2. So they are like terms, and you can subtract them by subtracting their coefficients. 6 minus 3 gives you 3p squared. Okay, you do have to copy down the variable part as well. Okay, let's keep going. Okay, how about 5? I'll use q this time, 5q squared plus 10q minus 2q squared. All right, 5q squared plus 10q minus 2q squared. So first of all, are they like terms? And for this one, I see that the 5q squared and the minus 2q squared, those are like terms. They both have the letter q, both raised to the same exponent of 2. The 10q, while it has the letter q, it's not raised to the same exponent as the other ones. So you cannot actually, it's not actually a like term with the other ones. So in this situation, what you would do is you would only simplify the q squareds. So combine 5q squareds and minus 2q squared. That ends up being 3q squared. Okay, if we did 5 minus 2, you have to take into account the sign that's matching with the coefficient, and that's a minus sign. But then you have to remember to copy down the plus 10q. That did not simplify, but it also does not go away. So you copy down anything that did not get simplified. Okay, we got to keep going on this. Lots and lots of situations that you can run into. So number 6, how about 7a cubed plus a squared plus 10a cubed plus 4a squared. Okay, so we can try this one. So you ask the question, are they like terms? Well, they're kind of two pairs of like terms here. 7a cubed plus 10a cubed. Those are like terms. They both have the variable a cubed. But different like terms are positive a squared plus 4a squared. Okay, they're all the letter a, but the exponents distinguish the two types of terms. So in this case, you're allowed to simplify the a cubes together. So 7a cubed plus 10a cubed makes 17a cubed. And you're allowed to simplify the a squareds together. So 1a squared plus 4a squared, that will make 5a squared. And that is all we will do for question 6. Okay, the a cubed cannot be added to the a squared. You can imagine a cubed as actually cubes, like dice. So we have 17 dice, and we can imagine a squareds as squares. So just like a sheet of paper that's in the shape of a square, and you have 5 of them. Okay, you have 5 of them, and you have 17 cubes. This could take a long time to draw, so 17 of them. So you can ask, what happens if I take 17 cubes and I add them to 5 squareds? Well, you can't really add them. They don't turn into a different shape or anything. All you have is, you're just going to have those 17 dice and those 5 pieces of paper. Okay, they don't suddenly combine and morph into something cool. You just have those two sets of things. Actually, what I'm trying to say is that there's no way to really combine them together. You're just stuck having to write them out separately. Okay, so that's kind of a visual example of why you can only add like terms. Okay, now let's start doing examples with multiple letters. For example, 2x y plus 8xy. So, can you add those together or not? Can you add those together or not? So are they like terms? They are. They have the exact same variables with the exact same exponents. The exponents are 1. So they are like terms. We can combine them together by adding their coefficients. 2 plus 8 gives you 10. And then you have to copy down the variable part as well. Whatever xy represents, you can even imagine xy as the area of a rectangle. If you think about it, length times width, x times y. So you have 2 of these rectangles and you add 8 of these rectangles. What do you get? You get 10 of these rectangles. Okay, but you do have to write the xy there. You can't just write the number 10. And they don't start turning into rectangular prisms or anything like that. They stay as rectangles. So you're not adding any new exponents or anything like that. There's a lot of me talking about what to do and what not to do during this one. Okay, how about this? Let's say 4 a squared b plus 6 ab plus 3a squared. Okay, we will do this one. So we ask, are they like terms? And the answer is actually no. None of these 3 are like terms to each other. We can try to compare the first 2. We will find that those are not like terms. Why not? Because the a's do not have matching exponents. So they are not like terms. We can ask, what about the second and third one? Are they like terms? The answer is no. The second one has a b in it. The third one does not have any b in it. Plus the a's don't have matching exponents anyway. So then we can ask, what about the first and the third one? Are they like terms? They both have a squared in it. So it's pretty close, but the answer is still no, because the first term has a b along with it, and the third one doesn't. To be like terms, they have to be totally exact in every way in terms of the variable part. So we actually have no like terms here. So this is a trick question. When I say simplify this, you cannot. Okay, you cannot simplify further because there are no like terms to add or subtract. Okay, let's keep going. Let's say 4x squared y minus 5xy squared minus 2y squared x. Okay, so do we have like terms here? And if you can pause the video if you want to think about it and see if you're right or wrong. But it turns out that we do have like terms, and I will underline them. So the second term and the third term are actually like terms. How come? Because they have the exact same variables raised to the exact same exponents. They have an x to the exponent 1, and they both have a y to the exponent 2. So they're exactly the same. So those are actually like terms. We can combine them. They are both different than the first term because the first term has a squared on the x. So that's different than the other two. So, so only those two yellow ones are the like terms. So we can combine the like terms, and remember what you do with any terms that don't have any like terms. You still copy it down. You don't do anything to it, but you still copy it down. It does not just disappear. Okay, so I've copied down the first term. Now the second and third terms, let's add them together. So be very careful that you see the negative signs. We are talking about integers here. We have to add -5 and -2. -5 and -2 added together makes -7. Two negatives added together becomes more negative, so we get -7. Now, what about the variable part? Do we write xy squared or do we write y squared x? It does not matter. They are equivalent. My preference is to write in alphabetical order, so I'm going to write xy squared. Okay. And we can't stop at 9. We should stop at a nice number like 10. Okay, so let's try one more here. I will say -p squared plus 4 p squared q plus 7p squared minus p squared q squared. Okay, that'll be the last one. So we have 4 terms that we may or may not be able to simplify, to add or subtract. You can only simplify like terms. So I look for like terms. I'll start with the first term, which has variables p squared and nothing else. So I look at the other 3 terms and ask, are any of those the exact same? It's p squared. And only the third one is. While the other 2 terms that I have not underlined yet, they both have p squared in it, which seems to match. Unfortunately, they also have q's in them, and that actually makes them not like terms anymore. By the way, not like terms, we usually just say unlike terms as a simpler word. So we can combine the p squareds. Let's look at the second term, p squared q. So we can ask, is the fourth term, the last one we haven't underlined yet, is that one a like term with it? And it's not. It's not, because, so I'll underline it red. The blue and the red ones, while they both have p squared, and that matches, their q's do not match. One of them's q, one of them's q squared. That does not match. So they are not like terms. So at the end of the day, we can only add the ones underlined in yellow. So that's -1, because negative p squared is -1p squared, and then plus 7. What's -1 plus 7? You can maybe visualize a number line. You start at -1 and then you go into the positives. You will end up at 6. You'll end up at positive 6p squared. Now the blue and the red terms cannot be simplified. So all you do is copy them down as is. And that would be the answer. You cannot go further than this in terms of simplifying. So I'll kind of summarize that at the bottom here. To simplify polynomials, we're going to do two things. We will add or subtract any like terms, but also copy down, okay, also copy down terms without like terms. Okay, so like don't forget about them is what I'm trying to say. Okay, so that is the gist of it, and you should practice this a lot. I will post that for your classwork.